I'm here with Clément Mouhot from the University of Cambridge, and we're at the International Congress of Mathematicians here in Rio. Clément, you work on partial differential equations and mathematical physics. Can you give us an idea of what that area involves and what drew you to that area?
So it's an area that's part of a broader continent called mathematical analysis, and it's mainly devoted to understanding better some of the hardest nonlinear equations we found in physics. I should say maybe theoretical physics. That's why we call it also mathematical physics. So to give an idea, it's not experimental at all. It's actually very pure in some sense, even if I'm not sure the adjectives pure and applied are very useful. But mathematics is a science of structures, and the main equations of physics are some of the most beautiful structures we can find, because they are rich and they are rigid. A structure needs to have rules and rigidity, and needs to be deep, that you find more and more when you dig.
And Clément, you were invited to give a lecture here at the ICM. Can you give us an idea of what you talked about?
So I chose to present a recent series of works I have done with some collaborators in Paris and Chicago mostly, also Austin, Texas. But also I also, as is customary in these ICM talks, I also reviewed works of other groups. So all these works are related. They are about a new line of research we started about 3 years ago with 3 collaborators. That is doing something that we like to do very much in mathematics, which is to bridge different areas, different theories together. So this line of work is trying to solve some conjectures for a class of the equations from physics that we call kinetic equations. But the way we try to do this is maybe even more important than the questions we try to answer. We are trying to combine several major theories of analysis of PDEs of the 20th century. They involve some names that are quite famous, even in the general public. So Nash, so the Nash of the Hollywood movie. De Giorgi, Ennio De Giorgi, one of the greatest Italian mathematicians of the 20th century. Jürgen Moser, a German mathematician who did most of his career in the US, in dynamical system and PDEs. And another very famous mathematician called Hermander, in Europe this time. And so we are trying to combine the main theories of so-called De Giorgi, Nash, Moser, and Hermander to try to solve questions.
And how are you enjoying the ICM? Have you had any particular highlights so far?
Well, I liked very much several of the plenary talks. I liked broadening my mathematical culture, going to other sessions, seeing the latest results in my field. So all of these things are very nice, obviously. There's one good aspect I wish to stress in the ICM is I like the fact that mathematics is very international. This shows internationalism beyond language, culture, religion. That is really great. There's also a negative side of the ICM, and I'd wish more colleagues talk about it. There's a growing trend towards individualism with more and more prices, and also playing the mediatic game more and more, trying to sell some well-marketed images of geniuses. And there's a cognitive dissonance in that, because every serious mathematician knows that the prizes are given to good people. I don't think we ever give prizes to people who don't deserve them, so I'm proud of that in mathematics. But the choice is largely arbitrary between great mathematicians. So, and then we sell in this congress these few as the big geniuses of the time. So I don't think it's very much compatible with the ethics of truth in mathematics. We oversell things to the media to be visible.
And one thing that's been apparent to me going to the lectures is how much of it is about collaboration and teams of mathematicians either working truly together within departments or collaborating internationally.
Yeah, in some sense it's always been like that because mathematics is about finding new viewpoints, making new connections. Of course, you do it when you work alone as well, which is one of the pleasure of doing mathematics, but you can do it better maybe when you discuss with others. So I think it always existed in the history of mathematics. What's new is because I think of the technology of transports that improved in the 20th century and more recently emails, Skype, all these things. It has become much easier to write paper together. That is the big change. Now probably most of the papers written in mathematics on the planet are papers written in collaboration. But there's a good reason for that is that it is genuinely hard to write mathematics, and the process of writing is usually more fun when you do it with the colleagues.
Well, thank you very much. I hope you enjoy the rest of the Congress.